So to go a little bit into how these things look and how the different systems get grouped together. So the unsupervised learning I've talked about, it's a sort of clustering applications, and an obvious one there is also product recommendations. So if you're watching something like Netflix, you're listening to Spotify, most of the online media companies to some extent are using this. Also, if you're shopping on any online website I mentioned earlier, those recommendations, it's basically clustering you together with other clients who have similar behavior, similar interests, and then it can start seeing, okay, well, what have they bought, what do they like that you haven't looked at yet, and it can start filling in those gaps. We use the same thing for fraud detection. We use both unsupervised and supervised learning and fraud detection, but unsupervised learning is quite good at clustering groups of transactions, for instance. So you can start seeing the clusters that don't conform, or outliers, or things that conform to clusters that we know are likely to be fraudulent. So it's pretty useful there. On the supervised learning side, it's quite useful to think about the following three areas. Basically, it's natural language processing, which is anything where we have unstructured communication, so voice data, text, and we can turn text into voice, we can turn voice into text, we can look at the sentiment of sentences or of speech. We can do machine translation. Anything where you're really trying to make a decision based on text would fall under natural language processing. Computer vision would be all the things that look at an image or a video feed, so facial recognition, self-driving cars, X-rays, MRIs, but also the quality control in factories and in pizza shops apparently these days. And then anything else where you're getting from input to output, I've lumped into other predictive models, which which are just cases where you have some bit of information and you need to make some decision or classification or output from that. So this has all been quite theoretical, and I'm going to get into two examples. The first one quite straightforward, and the next one a bit more complex. So this first example, basically, I took clustering and natural language processing, and I quite like to monitor sentiment and to monitor what's being talked about in the news and on Twitter. So amongst one of my many data sets, I recently pulled some data on how do people feel about also some of the banks with relation to various topics. And one of those topics was COVID-19, but I essentially used a topic modeling system to look at all of the tweets going on, determine what are the groupings within these tweets, and then I pulled the COVID grouping from there and ran a sentiment analysis algorithm on that. And what you can see here is a little bit of an idea of across these 5 banks, and their colors are randomized and they're not necessarily the banks that you think they are. But how has it been going in terms of the sentiment about COVID over the last few weeks? And you can see 2 of these banks did pretty well initially. Then something happened and suddenly the sentiment was much less positive. The other banks has been doing okay, a little bit below the line, but I think Twitter tends to be quite negative as a rule. So being close to that halfway line is generally okay. But as a manager, you might want to look at this or look at different topics and see, okay, what happens around that time? Why are customers suddenly less positive? Or looking at different topics and see which of those topics are we as a company doing well in versus our competitors, and what are the ones where we're lagging? And can we then dig into that information a bit more and find the source of why people prefer our competitors to us, or why we're strong in the other areas? So this is something it's a very simple example, but it has fairly big applications in terms of understanding customers. And it's a pity there's no one from marketing, according to the survey, around, because there's a lot of applications in the marketing space. The next one I worked on, which is one of my favorite recent projects, was working with a chronic patient care company. And they employ coaches to help these people adjust their behavior to deal with their chronic illness. So we use both supervised and unsupervised learning here, but this is specifically the unsupervised learning example. So in this company, the clinical team had a hypothesis about certain types of patient profiles. And they would say, well, we have some patients that typically listen well to our advice, and then they get better very quickly. We have some that, and you'll see that second graph, the one that says need supervision. Those are ones that they're, here a low reading is good, so their readings decline and get into a good range, but as soon as they are in between coaching sessions, it goes back up. We saw some people completely not respond, some people revert. These are just demo examples. The actual set of profiles was much more complex and took a lot of variability into account, and I can't share for client confidentiality reasons. But this gives you a little bit of intuition. We were able to use the system to find these patterns that the clinical team believed existed, to validate that yes, they are in fact there. There was some differences, and there was actually a new pattern and a little bit more nuance amongst the patterns. But for the most part, we validated yes, those patterns are in fact there. Some of them are not as common as you believe, and now we can help you as a company to classify patients very quickly and with a high degree of an increasing degree of confidence as the system learns. And then help your coaches understand and react correctly to these different types of patients. And this then also is forming the baseline for further machine learning and further guidance systems to help improve this coaching process. So this has been a very, very interesting example to work on. And I think very similar logic can be applied to thinking about education, finding different profiles of learners, or thinking about employees, finding different profiles of employees, and then seeing what type of coaching, mentorship, intervention works best, and also identifying people who are likely to underperform at an earlier stage, and then finding ways to engage with them as well as possible.
Renier, just a quick question on that. Looking at those graphs, I'm taking a random guess here that it's something about insulin and blood glucose control. Are you aware of any examples within the financial services industry where a similar sort of principle is used to monitor people's spending behaviors and likelihood to default on loans, or exceed their overdraft limits, etc.?
Oh, fantastic point, Ty. This obviously is not just something you can use in healthcare or education. It is very, very applicable to identifying types of borrowers. So thinking about people that are likely to follow certain behavior patterns, identifying early if someone is getting into a certain pattern, and then you can make your adjustments. If this person is displaying the right type of behavior, or if he matches the type of profile that we feel comfortable lending to, you can more aggressively promote loan products to that person. Or no, absolutely. In terms of understanding your risk and sort of risk monitoring and cross-selling, the same logic carries very well. You might also do this with supervised learning, especially banks in general tend to have fairly large amounts of data, which could be used to tackle this from the supervised learning side. But often a combination of different approaches will give you good insight, and this is something that can be used in that domain as well. To the extent that it's actively being used, there are definitely some banks using both approaches. Not sure about the local prevalence. That might actually be quite an interesting survey to run at some point.